Hello everyone, I am Kedar Visnay from CSCB section, SRIT from Computer Science and Engineering branch. Today's my topic is particle in one-dimensional potential well eigenvalue functions in physics. The definition of particle in one-dimensional potential is a fundamental quantum system where a particle of mass m moves along a single spatial dimension under the influence of a potential energy function. The eigenvalue functions uh, of the system describe the possible stationary states of the particle and are solutions to the time-independent Schrodinger's equation, that is minus h cut square by 2m into d square psi of x by ds square plus v of x into psi of x equals to e psi. Now, what is meant by eigenvalue function? The eigenvalue function for the motion of the particle within potential box is psi n of x equals to a sin n pi by a into x in the region of 0 less than x less than a. Now, explanation about particle in one-dimensional world. In quantum mechanics, a particle does not have a def defined position or velocity like in classical physics. Instead, it is described by a wave function psi of x, which gives the probability amplitude of finding the particle of position x, where psi of x is the wave function, v of x is the potential energy as a function of position, E is the energy of the particle, h cut is the reduced Planck constant. Here, A can be determined by using a property of normalized wave function, that is integration of 0 to a psi modulus square dx equals to 1. A square integration of 0 to a half of 1 minus cos 2 n pi by a into x dx equals to 1, where sine square theta is equals to 1 minus cos 2 theta. That implies we can see that a square by 2 into integration of 0 to a 1 minus cos 2 n pi by a into x into dx equals to 1. By integrating we get a square by 2 into x minus sine 2 n pi by a into x by 2 n pi by a to 0 to a equals to 1. That is a square by 2 of a minus 0 minus 0 minus 0 equals to 1. At both the limits, second term becomes equal to 0. That is a square by 2 into a equals to a square equals to 2 by a. A equals to root 2 by a. The wave function is psi n of x equals to root of 2 by a sin n pi by a into x, where n implies integer, that is n equals to 1, 2, 3 and so on. For n equals to 1, psi 1 of x equals to root of 2 by a sin pi by a x, which has two nodes. For n equals to 2, psi of x 2 equals to root of 2 by a sin 2 pi by a into x, which contains three nodes at x equals to 0, x equals to a by 2, x equals to a. For n equals to 3, psi of x into 3 equals to root of 2 by a sin 3 pi by a into x, which contains four nodes at x equals to 0, x equals to a by 3, x equals to 2 by a by 3 and x equals to a. And it goes on continuous. In the place of x, in the place of n, we can substitute 1, 2, 3 and something goes on. Psi 1, psi 2 and psi 3 are called eigenvalue functions. Characteristics of particle in one-dimensional potential wave. Quantized energy levels, that is the particle can only have certain discrete energy values. And wave-like nature, the particle behaves like a wave described by the wave function psi of x. Boundary condition matters. The shape of the potential v of x and the boundaries, walls, wells, etc. determined in the form of v of x and energy levels. And node structures, and the final one is normalization. And applications of particle in one-dimensional potential well. It is widely used in quantum dots and wells, atomic and molecular physics, laser technology like the energy level transistors between eigenstates are used in generating coherent light in lasers, and nuclear physics, quantum compiling, nanotechnology like nanoscale system often require quantum mechanism modeling using ID potentials for electrons and particles. Thank you for giving this opportunity.